NVIDIA says the next computing wave is not just chatbots, search boxes, or co-pilots. It is machines that can see the room, understand what changed, and act in the real world. That is the channel-style hook behind the title. NVIDIA did not single-handedly invent robots, and it did not make science fiction suddenly complete. What it did in 2026 was put a serious, full-stack platform around physical AI, world models, robot foundation models, simulation, synthetic data, and edge computers that can run on the robot itself. Here is why that matters. Traditional robots are incredible at fixed jobs. A factory arm can weld the same seam thousands of times. A warehouse robot can follow a map. But the real world is messy. A cable bends differently. A box arrives damaged. A human steps into the aisle. A door is half open. For a robot to be useful outside a narrow script, it needs perception, reasoning, planning, movement, and learning all working together. NVIDIA's pitch is that physical AI needs three computers. The first computer trains the robot brain. That is where large models learn from demonstrations, teleoperation, videos, sensor data, and synthetic examples. The second computer is the simulation world. This is where Omniverse, Isaac Sim, Isaac Lab, and Cosmos come in. A robot can practice in a digital twin before anyone risks broken hardware, damaged inventory, or a human standing too close. The third computer is on the robot. Jetson-class systems take the trained policy and run it at the edge, where milliseconds matter. The biggest bottleneck is data. Language models had the internet. Robots do not have an internet-scale dataset of every kitchen, warehouse, hospital corridor, loading dock, staircase, and cable mess they will ever face. Collecting that data physically is slow, expensive, and sometimes unsafe, so NVIDIA is betting heavily on synthetic data. One real scene can be scanned, reconstructed, varied, and stress-tested. Change the lighting, move the obstacle, add reflections, create rare edge cases. Run the same policy thousands of times in parallel. Then use those failures to make the robot better before it touches the real world. This is where Cosmos matters. NVIDIA describes Cosmos as a family of world foundation models for physical AI. In plain English, these models help generate and reason about realistic world states, so robotics teams can create more training data and evaluate policies faster. Then there is Isaac GR00T, NVIDIA's humanoid robotics model family. GR00T is not magic software that makes any humanoid perfect. It is a foundation that developers can adapt for vision, language, action tasks. See the scene, interpret an instruction, break it into steps, and produce actions for the body. That is the important shift. The robot is no longer only following a rigid script like move joint A to coordinate B. It is moving toward policies that connect language, vision, and action. In NVIDIA's official examples, this pipeline goes from teleoperation and sensor capture to simulation to policy training to hardware deployment. A robot can learn to fold laundry, manipulate objects, navigate around obstacles, or support industrial tasks. But every serious example still has a boundary. The task, the body, the environment, and the safety case matter. The most realistic first wave is not a robot butler in every home. It is factories, warehouses, logistics, electronics assembly, autonomous forklifts, inspection, and healthcare robotics. These are places where work is valuable, environments can be mapped, and companies can afford the engineering needed to make robots reliable. That is why the partner list matters. NVIDIA says companies across industrial robotics, humanoids, surgical systems, construction, logistics, and robot brain startups are building on its stack. The story is not one company replacing the whole robotics industry. It is one platform company trying to become the common infrastructure layer underneath many robot builders. But there are real risks. Simulation is powerful, but a simulation is still a model. If the digital world misses a weird friction effect, a cable snag, a sensor glitch, or human behavior, the real robot can fail. Synthetic data helps cover edge cases, but it can also teach the wrong lesson if the synthetic world is wrong. Safety is another wall. A chatbot can give a bad answer. A physical robot can hit a person, drop a tool, block an emergency path, or damage expensive equipment. That means certification, redundancy, monitoring, and conservative deployment will matter as much as model demos. And economics will decide adoption. A humanoid robot is impressive. A boring mobile robot that saves money safely may arrive first at scale. So, did NVIDIA make physical AI real? As a headline, it is a hook. As a trend, the answer is more precise. NVIDIA is making the infrastructure for physical AI far more complete. Training, simulation, data generation, robot models, and edge inference are becoming one pipeline. That is the breakthrough to watch. The future robot will not just be programmed line by line. It will be trained, simulated, tested, updated, and deployed like a physical version of modern software. And if that works, the next generation of automation will not live only on screens. It will move through factories, warehouses, hospitals, streets, and eventually the places we live. The real question is not whether robots are coming. It is where we will trust them first.